In setting up a network, having multiple paths between switches can be a good thing. These redundant links serve as backup paths for traffic to ensure reliability. However, without proper management, data packets might just keep bouncing between switches without ever reaching their destination. This causes what's called a network loop, which leads to congestion. Now, throw in broadcast frames. Those are the messages sent to all devices within a certain area, and you've got a recipe for trouble. If caught in a loop, these broadcasts can multiply, clogging up the network's bandwidth and potentially bringing it to a halt. To tackle this, you need the Spanning Tree Protocol, STP. It's like a traffic director, deciding which pathways to close off so data flows smoothly without any loops. Over time, different flavors of STP have been developed, each with enhancements to keep networks running more efficiently. But there's no universal best choice. It depends on your network's specific needs. In this episode of Cisco Tech Talk, I'll explain the distinct features and benefits of each STP variation. Next. I'll start with the original STP. It's defined by the IEEE 802.1d standard and is also known as Common Spanning Tree, CST. STP was designed to support a single spanning tree instance for the entire bridge network. This can cause slow convergence and less than optimal traffic flows. If you have a small, simple network, STP may be all you need. Per VLAN Spanning Tree Plus is a Cisco enhanced version that creates a distinct 802.1d spanning tree for each VLAN within the network. This means that each VLAN can have its own optimized path. This is done to improve network efficiency. However, if you have a lot of VLANs, you have to be careful. These individual instances increase the CPU and memory usage. If your network doesn't have the capacity for this, it can cause problems on the network. If you have a Cisco network with enough capacity and VLAN-specific optimization is important to you, this would be a good fit. Moving toward faster convergence times, Rapid Spanning Tree Protocol, RSTP, is defined by the IEEE 802.1w standard and also serves as an evolution of the original STP. RSTP significantly improves network recovery times after topology changes. If network uptime is your #1 priority, you may want to select RSTP. Rapid Per VLAN Spanning Tree Plus is Cisco's version of RSTP. It incorporates the benefits of PVST Plus, offering a separate instance of 802.1w for each VLAN. The blend of rapid convergence and per VLAN optimization makes it a good choice for Cisco-centric environments with multiple VLANs that need quick recovery from failures. The last option, Multiple Spanning Tree Protocol, MSTP, is defined by IEEE 802.1s. It takes a different approach by mapping multiple VLANs into a single spanning tree instance. Cisco's implementation of this is known as Multiple Spanning Tree, MST. This approach can reduce the resource load on network devices by decreasing the number of required instances while still providing faster convergence than the original STP. MSTP has VLAN mapping efficiency like no other. If you have a large network and are concerned about scalability, this may be a good option for you. On Cisco Catalyst 1200 and 1300 series switches, you have some detailed selections you can make for STP. In the Web User Interface menu under Spanning Tree, click STP Status and Global Settings. Here, you can adjust the spanning tree state, STP Loopback Guard, STP Operation Mode, BPDU Handling, setting path cost default values, and bridge parameters. One other option here is to switch the mode from Basic to Advanced in the upper right-hand corner of the screen. On this Catalyst switch, Advanced mode gives you access to more configuration choices when setting up MSTP and PVST. The options for STP vary based on the model of the switch. That's a wrap for this STP Beginner's Guide. Now you know the benefits and potential drawbacks of each and can decide which is the best fit for your network. Thanks for watching. I'll see you next time.